Hey scholars, I hope this video finds you well. You have reached a momentous point in Algebra 2. We are finally going to talk about this thing called the quadratic formula. It is a big deal, and it's going to help you to solve any quadratic equation or find the zeros of any quadratic function. Make sure you write the formula down, make sure you memorize it, and pay close attention. Let's get going. So the quadratic formula can be used to solve any quadratic equation that is in standard form, which is ax squared plus bx plus c equals 0. Or you could see a function that's in y equals ax squared plus bx plus c form, and it can help you to find the zeros of any quadratic function as well. Now, the quadratic formula, and this is what you need to make sure you write down, is x equals negative b, or you could say the opposite of b, negative b plus or minus the square root of b squared minus 4ac all over 2a. I'll say that one more time. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You need to be able to say it as fast as that. Memorize it. And I'm going to actually attach a link in the Edpuzzle that can help you to memorize it. It'll be a song that'll get stuck in your head. Also have a couple examples on this slide of how to use the quadratic formula, so look at those on Google Classroom. So here's our first example. We're going to use the quadratic formula to find the solutions to this equation. We're not finding zeros because we're not finding zeros of a function. This is an equation. We're going to find its solutions. Alright, so we have x squared equals 9x minus 20. The first thing I realize is that I do not have 0 on one side of the equation. So I need to make that happen. What I'll do is I'll just subtract 9x on both sides, and I'll add 20 on both sides. So that's going to make the right side equal to 0. So the new function is going to be, and I'll just write it right here, we're going to say x squared minus 9x plus 20 equals 0. I need that function to be in standard form before I can move forward. So this is going to help me to identify a, b, and c, which we're going to end up substituting into the quadratic formula. So a in this case is 1, b in this case is negative 9, and c equals 20. So now I want to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, at this point, since I know that, I just need to substitute. And let me not forget x equals, right? So x equals negative 9 plus or minus, so negative 9 squared. And remember to, when you're substituting, put them in parentheses. That's a great habit to always be in. Whenever you substitute, put in parentheses. A is 1, so we have negative 9 squared minus 4 times 1 times, and then c is 20. And then all of that is over 2 times 1. Well, now that I've substituted, I'm just going to try to simplify this. It looks complicated right now, but we're going to make it simpler. So negative 9 is going to be positive 9. And that's why earlier I said the opposite of b, that negative 9 ends up becoming positive 9 here. You just change the sign. Alright, so negative 9 squared is 81 minus 4 times 1 times 20, and I forgot to put the c right there. 4 times 1 times 20 is 80. So I'm going to say 81 minus 80 all over 2 times 1, which is just 2. So x equals 9 plus or minus. Now the square root of 81 minus 80, well, that's the square root of 1. 81 minus 80 is 1. And then divide that by 2. Okay, so we get x equals 9 plus or minus. Now the square root of 1 is just 1, divided by 2. Now, I can take this one step further. What's 9 plus 1? Well, it's 10 divided by 2. And then what's 9 minus 1? Well, that's 8, and then divide that by 2. So again, I said 9 plus 1 is 10, 9 minus 1 is 8, and those are both divided by 2. Well, I can find 10 divided by 2. That's 5. 8 divided by 2 is 4. So my solutions are 5 and 4. See how these solutions came out as whole numbers? That won't always be the case. We'll do an example like that next time. But we found the solutions using the quadratic formula. You may have already realized that you could factor this. This would factor as x minus 5 times x minus 4 equals 0. Well, then your solutions are x equals 5 and 4. And you may be like, Mr. Pittner, why didn't we just factor it? Well, you could have. That's what I just said. But you're not always going to be able to factor it. And so the quadratic formula is really helpful for solving problems where you cannot factor it. Let's try an example like that now. For this problem, we need to try to find the solutions of 2x squared minus 16x equals negative 27. This one won't come out as cleanly as the last problem. Check this out. We see, again, that this is not in standard form. If it's not given to you in standard form, we need to make it in standard form. So what I mean is I need to add 27 on both sides so that one side is 0. We want the right side equal to 0. So we get, I'm going to write this over here, we'll get 2x squared minus 16x plus 27 equals 0. So A equals 2, B equals negative 16, and C equals 27. Alright, so we have our quadratic formula, right again, x equals negative b plus or minus the square root of b squared minus 4ac, and that's all over 2a. So x equals, just substituting in now, negative 16. I'm going to skip a step. I know that's going to be positive 16. Positive 16 plus or minus. Now, negative 16 squared, I'll just substitute that in. We'll deal with it later. Negative 16 squared minus 4 times 2 times 27. All over 2a. Well, 2 times a, I can do this quickly. 2 times a is 2 times 2. 2 times 2 is 4. Okay. So, x equals, I'm going to start simplifying this. X equals 16 plus or minus. And then negative 16 squared is 256 minus 8 times 2 times 27. I'm sorry, 4 times 2 times 27. 4 times 2 is 8. 8 times 27 is 216. And then all that's divided by 4. All right, let's keep going. X equals 16 plus or minus. This is the square root of 40. The square root of 40. And that's all divided by 4. Now, the square root of 40 will simplify to 4 times the square root, it'll simplify to 2 times the square root of 10. So we get x equals 16 plus or minus 2 times the square root of 10. And that's all divided by 4. Now, here's what I'm going to do. I want to try to make this look a little simpler. So I can break this up. I'm going to break it up like this on both sides of the plus or minus. I'm going to say x equals 16 divided by 4 plus or minus 2 times the square root of 10 divided by 4. You see how I split it at the plus or minus right there? Well, this is going to make it a little simpler to simplify. Now, 16 divided by 4 is 4 plus or minus 2 times the square root of 10 divided by 4. Well, I can divide 2 and 4 both by 2. So 2 divided by 2 is just 1. So 1 times the square root of 10, we can just leave the square root of 10 in the numerator, and 4 divided by 2 is 2. So that'll simplify to square root of 10 over 2. So the final answer is x equals 4 plus or minus the square root of 10 over 2. This one didn't come out as cleanly. We call this an irrational answer. See how we have the square root of 10 in our answer and we cannot simplify that any further? Well, we call that an irrational answer when you have a radical that you cannot simplify any further. So this quadratic equation has irrational solutions, we would say. Here's our last example. Now we're trying to use the quadratic formula to find the zeros of y equals x squared plus 4x plus 5. We're going to say we're finding the zeros because this is a function. We're trying to figure out where it crosses the x-axis. Now remember, it may not cross the x-axis. We may see an example of that here. Alright, so anyway, to solve this, remember, to find the zeros, we want to set y equal to 0. So we're going to say 0 equals x squared plus 4x plus 5. So now I'm going to say A is 1, B is 4, and C is 5. And then we're just going to substitute that into our quadratic formula. So we got x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Hopefully you're starting to have that memorized. So I'm going to substitute in x equals negative 4 plus or minus, let's see, plus or minus the square root of 4 squared minus 4 times a is 1 and c is 5. So just substituting all these in, and then 2 times 1, we're saying 2 times a, 2 times 1, that's just 2. Okay, so now I'm going to move right here. Now, so we get x equals negative 4 plus or minus, well, 4 squared is 16. 16 minus 4 times 1 times 5. Well, that's 20. 16 minus 20 over 2. Now, x equals negative 4 plus or minus the square root of, well, 16 minus 20, that's negative 4. So, that's all that's over 2. Now, since we got that negative 4 under the radical, that tells us we're going to have an imaginary answer. We're going to have an imaginary number in our answer. So, let's try to simplify this. X equals negative 4 plus or minus. Remember, the square root of negative 4, we're going to have I in our answer. So, square root of negative 4 is 2I. Square root of 4 is 2, and then that negative tells you you're going to have I in your answer. And then we're going to divide that by 2. So x equals, remember you can break this up. We can say negative 4 divided by 2 is negative 2, and then 2I divided by 2, we're going to have plus or minus, 2I divided by 2 is I. So negative 2 plus or minus I. That's your final answer. So the zeros of that function are imaginary. This parabola, the parabola of this graph will not cross the x-axis. So check this out. It's going to look something like this. We know since a is positive, it's going to go concave up. So it's not going to cross the x-axis. So that parabola would look something like this. See how it's not crossing the x-axis and it's pointed up? All right. So we'd say it has imaginary zeros since it does not cross the x-axis. But anyway, we'll talk about that a little more in the future. Make sure you've got the quadratic formula down and you're getting more and more comfortable using it. So I hope that lesson was helpful for you. I know some of these problems were a little bit crazy, but if you know how to use that quadratic formula, you'll be just fine. We'll do some practice in our next class. Make sure you're prepared with questions and prepared to work. Good work today. Thank you, Collegiate Scholars.